In today's competitive market, organizations are constantly seeking ways to improve their operations, enhance quality, and reduce costs. The integration of simulation with Lean Six Sigma and Design for Six Sigma provides a powerful framework that can achieve these goals. This book, Simulation-Based Lean Six Sigma and Design for Six Sigma, by Bassem Elhaik and Raid Al-Omar, offers a comprehensive guide for practitioners and academics looking to leverage these methodologies. By blending theoretical foundations with practical applications, the authors present a holistic approach to process improvement that is applicable to both manufacturing and service sectors. The book is structured into 3 main sections, each addressing critical components of Six Sigma. The first part introduces essential concepts such as the define, measure, analyze, improve, control, demake framework, which serves as a systematic approach to process improvement. This section also delves into lean principles, focusing on waste reduction while maintaining product quality. The authors emphasize the importance of adopting a holistic approach to quality that encompasses not only product or service output, but also operational efficiency across all business processes. In the second part, the book focuses on simulation fundamentals, specifically discrete event simulation, DES. Here, the authors present a structured overview of how simulation modeling can be applied to analyze real-world systems. They discuss various aspects of DES, including system modeling techniques, key components like event activation and time advancement, and the significance of using simulations to evaluate different operational strategies before implementation. A critical aspect highlighted is the necessity of accurate input data for effective simulations, a challenge often encountered in practical scenarios, which can be mitigated through structured methodologies found within Six Sigma practices. The final part of the book provides comprehensive roadmaps illustrating how to effectively integrate simulation with Lean Six Sigma and DFSS projects. The authors outline specific case studies demonstrating practical applications of these integrated approaches in real-world settings. For example, they showcase how simulation techniques can be employed at various stages of the DFSS process, particularly during the characterization and optimization phases, to ensure that proposed designs meet customer requirements effectively while managing risks associated with potential design failures. This section underscores the synergy between simulation tools and statistical analysis methods traditionally used in Six Sigma initiatives. By linking theoretical concepts with practical case studies, the authors provide an invaluable resource for professionals seeking to enhance their understanding of both simulation methodologies and Lean Six Sigma practices to drive continuous improvement in their operations. Overall, this publication serves as an essential reference for anyone looking to deepen their knowledge of simulation-based Lean Six Sigma and Design for Six Sigma methodologies. Its clear structure allows readers to navigate complex topics while providing insights into best practices that can lead to improved organizational performance through effective process design and management strategies. Chapter 1. Introduction to Six Sigma Methodology. They discuss the demake framework, which serves as a systematic approach to process improvement, and introduce lean principles that focus on waste reduction while maintaining product quality. The authors emphasize the importance of adopting a holistic approach to quality that encompasses not only product or service output, but also operational efficiency across all business processes. Chapter 4. Overview of Lean Manufacturing and Value Stream Mapping. This chapter delves into lean manufacturing principles and the integration of lean techniques into manufacturing processes. The authors discuss the importance of reducing waste and improving efficiency through lean methodologies. They emphasize the significance of understanding the 7 types of waste in lean manufacturing and how to identify and eliminate them. The chapter also introduces value stream mapping, VSM, as a critical tool in visualizing the flow of materials and information in a manufacturing process. The authors highlight the role of VSM in identifying inefficiencies and optimizing processes for better performance. Chapter 6. Detailed Summary of Lean Manufacturing Principles. This chapter provides a comprehensive overview of lean manufacturing principles, focusing on the integration of lean techniques into manufacturing processes. The authors discuss the importance of reducing waste and improving efficiency through lean methodologies. They emphasize the significance of understanding the 7 types of waste in lean manufacturing and how to identify and eliminate them. The chapter also introduces cellular manufacturing as an innovative approach that enhances flow efficiency by organizing workstations into self-contained cells. The authors highlight the benefits of cellular manufacturing, including increased productivity, flexibility to meet diverse customer demands, and enhance competitiveness by reducing transport costs and production lead times. Chapter 7. Summary of lean techniques in manufacturing. This chapter delves into specific lean techniques used in manufacturing processes, such as just-in-time, JIT production, Kanban systems, single-minute exchange of die, SMED, and total productive maintenance, TPM. The authors discuss the importance of GIII production in reducing excess inventory and associated costs. They emphasize the role of Kanban systems in facilitating the movement of materials through the production process, ensuring that parts are produced or ordered only as required. The chapter also highlights the benefits of SMED in streamlining setup processes and reducing changeover times between different product runs. Finally, the authors discuss the importance of inventory reduction in lean manufacturing and the role of just-in-time inventory systems in optimizing resource allocation and reducing costs. Chapter 8. Introduction to Discrete Event Simulation. In this second part, the authors provide a detailed overview of discrete event simulation, DES, a powerful modeling tool used for analyzing and optimizing business process. The authors explain how DES is used to model complex systems characterized by discrete events, allowing for the analysis of transaction-based processes. They discuss the importance of validating the accuracy and applicability of these models, and how decision-makers can leverage the results to propose various what-if scenarios. The authors also highlight the advantages of using DES in optimizing production systems and improving customer service in various industries. Chapter 10. Simulation Process. Fitting Probability Distributions. This chapter focuses on the process of fitting probability distributions to observe data in simulation studies. The authors explain how this process is crucial for accurately representing real-world systems in data models. They discuss various statistical distributions used in manufacturing contexts and how they can be applied to model different operational variables. The authors emphasize the importance of verifying and validating the models to ensure that they accurately represent the real-world systems they are intended to simulate. Chapter 11. Simulation Process. Model Building and Logic Design. This chapter delves into the model building process in simulation studies, focusing on the creation of models that accurately represent real-world systems. The authors discuss the importance of gathering relevant data on system parameters and how this data is used to build simulation models. They also explain the role of model logic in defining the interactions between different components of the system. The authors emphasize the importance of verifying and validating the models to ensure that they accurately represent the real-world systems they are intended to simulate. Chapter 12. Simulation Process. Running and Analyzing Results. This chapter focuses on the process of running and analyzing simulation results. The authors discuss the importance of running multiple replications of the simulation to capture variability in system behavior. They explain how to collect and analyze statistical measures to assess the performance of different solutions. The authors also discuss how to use simulation outputs to evaluate the effectiveness of different solution alternatives and make informed decisions. Chapter 13. Integrating Simulation with Lean Six Sigma. This chapter focuses on the integration of simulation with Lean Six Sigma, providing a structured roadmap for implementing simulation-based approaches in Six Sigma projects. The authors discuss the importance of integrating simulation with Lean Six Sigma methodologies to enhance process performance and quality. They provide examples of how simulation can be used to evaluate different operational strategies before implementation and highlight the significance of accurate input data for effective simulations. Chapter 14. Simulation-based design for Six Sigma, DFS. This chapter focuses on the application of simulation-based methodologies in design for Six Sigma, DFS, providing a detailed overview of the DFSS process. The authors discuss the importance of identifying customer requirements and translating them into design parameters, as well as the role of optimization techniques in improving design performance. They also provide examples of how simulation can be used to evaluate different design concepts and refine them based on performance metrics. Chapter 15. Practical Case Studies. This chapter provides practical case studies demonstrating the application of simulation-based approaches in real-world settings. The authors provide detailed examples of how simulation can be used to evaluate different operational strategies before implementation and highlight the importance of accurate input data for effective simulations. They also discuss the role of simulation in optimizing design performance and improving process performance. In conclusion, the book Simulation-Based Lean, Six Sigma, and Design for Six Sigma provides a comprehensive guide for professionals and academics interested in the intersection of Lean Six Sigma, Design for Six Sigma, and simulation methodologies. By blending theoretical foundations with practical applications, the authors present a holistic approach to process improvement that is applicable to both manufacturing and service sectors. The book's clear structure allows readers to navigate complex topics while providing insights into best practices that can lead to improved organizational performance through effective process design and management strategies. Embracing continuous improvement through these methodologies is essential for organizations aiming to stay competitive in today's rapidly evolving business landscape.